Okay, let's get started. Today is 25th November 2025. So let's get started from the first, Miyashi.
So from the top here, so we've been doing some failover testing. We did essentially a cluster rebuild exercise. We wanted to bump our Kubernetes versions and OS versions. So what we would do is essentially fail over all 10 applications, at least the ones who have onboarded, to a different cluster that's already been upgraded. And what we noticed is that there are cases, this doesn't happen very often, but there are cases where the draining actually can take roughly about a minute. And that's because Karmada is flooding the original cluster with a lot of deletes. And so this is starting to essentially cause an event storm on that Kubernetes API server. And so it takes some time for all those events to finally get read through and for all the Flink deployments to be fully deleted. And what we've noticed is that since Karmada is immediately rescheduling these deployments, sometimes the latest checkpoint is actually in the process of still being cleaned up. And so there are cases where the Flink deployment will attempt to start from a latest checkpoint, which has been cleaned up from the previous cluster. Um, the way to get around this is what I did was essentially mark the destination cluster as no schedule. And then what I do is I allowed the first cluster to fully drain, and then I rescheduled all applications, and that seemed like it resolved everything, where all of the latest checkpoints were actually pulled correctly. They weren't any checkpoints that were in the middle of being cleaned up. Um, so the question here is there sort of any programmatic way to delay rescheduling in Karmada after it's been evicted from a cluster? I tried to look this up, but I couldn't really find too much information about this.
So hold on, I just see Kevin joined the meeting. So Kevin, can you hear us?
Hello.
Hello, hello. So how about let's uh, talk the second topic, and how do you think, Miyash?
Sure, that's fine.
Okay. So anything? I see you made an update on the proposal, right?
So I didn't push some changes that I've been meaning to update just yet because I've been working through some of the options here. But I added an entire section that's dedicated to indexing options. Um, so perhaps I can share my screen and maybe go through it real quick.
Okay, go ahead.
Can you see my screen?
Yeah, sure. I
Yeah.
can see.
Okay.
Yeah.
So this is sort of still in progress. So if there are comments, please go ahead and stop me. Essentially, what I wanted to highlight in the proposal is that this is a two-step process. So the first thing is whenever we start the scheduling cycle, we first need to determine whether the cluster candidate that we're trying to schedule our workload to will violate its own affinity terms. And then secondly, once we determine a cluster that won't violate its own affinity terms, we need to understand whether there are other workloads currently scheduled on that cluster with their own affinity terms that we might violate. So it's a two-step process. Essentially, what I was considering doing was something that's similar, I guess, in the Kubernetes world, where during each scheduling step, they're simply like memoizing scheduling decision based on the affinity terms. So in this case, we could have some sort of policy agnostic affinity or anti-affinity key that would let like our scheduler reason about the inter-workload anti-affinity and affinity across all the clusters. So instead of building a key from like a specific policy or workload term, we can use a canonical tuple of the attributes for the workload that's being scheduled. So in our instance, for example, if we have a specific anti-affinity term that's defined in the propagation policy, we would just take that term, the namespace scope, as well as any label key and value that's being tracked as part of that anti-affinity term or affinity term, as well as the topology key. And so this would essentially track clusters that already have a workload of this exact policy that's been scheduled, and we can just filter that cluster out in the beginning if it's already been scheduled to that cluster. Um, Now, this does require some other index structures. So, what I defined was kind of, I'll go through them one by one. But the first is just a way for us to be able to track um, different types of resource bindings based on the namespace scope as well as their label key and values. And so this allows us to determine essentially peers or groups of resource bindings that match label selectors for the workload that we're trying to schedule. Um, so for example, if I was trying to schedule a workload with an anti-affinity term that states you should not be scheduled on a cluster with a label that states like your environment is production, well then in this case we would look at postings namespace, whatever the namespace is we're trying to schedule to, environment, and then production, and see which resource bindings already have the exact same namespace and label key and values. So that would be our peer group, and we can kind of traverse that peer group and find the clusters that those peers have already been scheduled to. And that way we can kind of filter out those clusters from our scheduling candidates, since we don't want to be placed on any cluster that has a workload of that namespace with those label and keys. Now, for the second portion, we need to also take a look at the actual owners of a specific anti-affinity or affinity term. And this is for the step two of the checks that I had described in the beginning of this section, where we're looking at workloads that might also have affinity terms. And so what this would do is and we need to figure out what a correct like binding ID would be. For example, I sort of just added pseudocode here. But if we can search through a binding ID for a specific topology key, which in our case would just be whichever clusters we want to schedule potentially to, we can fetch back, oh, oops, I'm going over the wrong thing. Um, this, I'm talking more about the actual owners of a specific topology. So in this case, we want to track workloads with existing anti-affinity or affinity terms. And so that way we can kind of loop through those owner summaries, which would include specifications for their anti-affinity or affinity terms, and allow us to determine whether the workload that we're trying to schedule would violate any of these terms that are defined in the owner summary. And then finally, once we make a scheduling decision, we can compute this anti-key and update the memoize this value into some cache. And that way, in the future, when the scheduler does another cycle, if there's another workload of a matching policy or term, it will be able to check this in the cache first before having to go through this entire computation. So if we're going through like a step-by-step process here, the way that this would typically work is when we begin our scheduling cycle, we build the anti-affinity key or affinity key. If forbidden, which is just the name of the cache that I had created, if the key already exists there, and we find a specific cluster matching its topology value, we would just reject that cluster from the feasible clusters. And then otherwise, we would continue on with the remaining clusters that haven't been rejected. So with this posting map, which is just the maps of the namespace label keys and label values, this would map to the set of matching resource bindings. And that way we can kind of determine, okay, what are the peers in our group that we have to check against? And then we can start to sort of loop through those peers and determine which clusters those peers are actually scheduled to, so we can filter those out as well. And then finally, which I had mentioned as well, like for each destination cluster that has not been filtered out, we have to refer to the owners by topology map and check which workloads have existing anti-affinity terms and whether those affinity terms would cause conflicts with our workload that's about to be scheduled. So yeah, I guess the two-step process is a bit complicated. I also started to add in the scheduling groups idea that you had, Kevin. Um, but I was struggling a little bit to understand how this would work in an anti-affinity setting, because with at least affinity, I think what you had been getting at was that we can sort of schedule two or more workloads with matching affinity groups as one unit to a cluster. But with anti-affinity, I'm not really sure how that would work. So perhaps we can discuss that as well, just so I can be clear on that. But yeah, so generally that's sort of the option that I had been thinking about. Like regardless of what we do, we're going to have to update the scheduler, and we're going to have to improve, make some changes to the cluster info and cluster snapshot to include some of these resources.
Yeah, thanks for the update. There are a lot more details, and that's very helpful. Um, I'm just curious if you go through the option one. You trying to index by labels, right? Labels on the workload. Um, we have seen a lot of case that the workload may have their own label key value, like key is app and the value is exactly the workload name.
Mm,
I'm wondering maybe the size of the index will be very large.
yeah,
Yeah,
that's possible.
yeah.
Mm.
And also we need a kind of locking mechanism, or we need to kind of using copy snapshot mechanism on the index when some of the some of the worker are reading using the index while some of the other worker may be help updating the index. Yeah, so that's kind of thing we need to think about on that. For example, the informer need is focuses on updating the index, but when doing the scheduling, we that's the reading the index, right?
Yeah.
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 If
When I
we
was
can find a way to limit or just the sum, focus on some of the label key value, especially the label keys, would be that might be helpful to reduce the size of the index.
if we just focus on the key, you said?
I mean, if we just focus some of the key, But it would add a requirement on to the like cluster basically the system admin that they need to kind of indicate which kind of label keys will be used for you know uh, setting the affinity or anti-affinity term.
Okay, I'm actually really happy you brought that up because it's an edge case that I was thinking about as well. Like for example, let's take for instance that we have propagation policy A on namespace foo with workload A scheduled to cluster A, right? This workload has a label um, env prod. Now, in the future, user creates this propagation policy has anti-affinity term
Mhm.
with label selector env prod, right? So
Mhm.
Mm.
what that would mean is during scheduling phase, how would we know that cluster A already has workload with label env prod scheduled there? Because this anti-affinity term wasn't even created when this original workload got scheduled, right? So we have no way to know which label we actually need to keep track of in our indices. So perhaps this is just a case that we don't support, where we say, okay, if you're defining an anti-affinity term or an affinity term on your propagation policy, it's only going to work for workloads that are mapped or controlled by your propagation policy that has the anti-affinity or affinity term. So this concept of, okay, anti-affinity would also work for a different workload controlled by a different propagation policy on the same namespace. That's something that we wouldn't support. It would just be something that is supported by, like within the workload group, tracked by the propagation policy. Does that make sense? I'm essentially just trying to decrease the um,
Yeah.
sample size of the amount of labels that we actually have to keep track of. Because at least in this case, um, now that we have with anti-affinity term tracking and prod label, we only have to track the env prod label for resource bindings being scheduled. We wouldn't have to check any other label.
Yeah. Yeah. So yeah, I think the idea we have the similar idea. So basically trying to reduce the basically the size of the index. The only difference is how to tell basically how to tell scheduler which set of labels we want to index, right?
Hmm.
I think we can maybe try just the sum of the path and we can figure out what which is more practical. Yeah.
Could you repeat what you said? The sum of the, sorry, I didn't.
So my idea is I think you got one of the option is we limited only to the propagation policy that different workloads uh, kind of mapped by the same propagation policy. We index
Mhm.
the label for them.
Yeah.
And my option is that we can, for example, we use a configuration from a separate configuration file, maybe defined by the admin that, like in our Karmada instance, we only use like env or some of other limited keys for the key to uh, indicate affinity or anti-affinity. So basically, let someone tell the system only index this set of label keys. Yeah.
Okay. Yeah, that makes sense.
Can be one of the
Yeah,
options. Yeah.
yeah. The idea is maybe we can have some predefined label case,
Yeah.
and for take the example above, we can during the first step when we trying to uh, propagate workload A, we can set a, a value, set a static label to the workload, and then since the label key is predefined, so uh, we can build the index by the key, and when we are going to schedule workload B, so we can easily get all the workloads with the predefined key. Is that the idea?
Yeah.
Yep, I think that makes sense. However, we're not going to limit the values for the label, right? So for example, if we want to do something like we're using a label selector that's looking for an app label, right? There might be cases, at least
Yeah, we don't need to limit the label values because the label value may varies. But the label key, limiting the label key would be very helpful, I think.
correct. But what I was trying to make clear though is for the label values, with anti-affinity, for example, we might have two applications that both have app indexer,
Hmm.
for example.
Hmm. Hmm.
So deployment one, deployment two. So I just want to make sure that we're going to be keeping track of shared values as well and filtering out those clusters out of the scheduling candidates, since I think we're going to be tracking based off of like what the value of the label that we're interested in is.
Yeah, actually, that also depends on how you provide the API. Like for Kubernetes, we actually even provide the flexibility for users to indicate like I want to enter affinity all the pods that has a certain key no matter what the value of the labels are.
Mm,
So that's also possible. Basically, try to stay away from all the pods that has a label key app, no matter no matter what the label values are.
got it.
That's also possible. It depends on our API design.
So at least in the affinity term, the way that I defined this was this label selector is something that we would look for in terms of just the key for the label. And then for match label keys, this would be ANDed with the label selector, but we would be matching workloads that share the same value for a specific label key. So for instance, like in our propagation policy, what we would do is, okay, the label selector for this application is app tier prod, but then we would also map based on this karmada.io/group label. So if the workloads share index or job as the value, they would be scheduled to different clusters. However, I could maybe simplify this.
Sorry, I have to jump.
That's okay.
You can continue.
No worries. But okay, that was really helpful. Thank you.
Thank you.
Okay. Okay. So so speaking of the API design, I think the Kubernetes affinity is pretty complicated, I think.
Yeah.
So I was thinking, do we really need that all? Do we really need all those fields? So the idea in my mind is maybe we just need the term to select the workloads you want to affinity or anti-affinity. So,
Uh,
for instance, do we really need the topology key?
um, no, I don't think so. I can look this over again, but essentially all the topology key is doing is determining which clusters we're scheduling to. So maybe we can
Yeah.
just use the cluster affinity that we've already defined in the resource binding, and that way we can kind of filter out which clusters are relevant and which aren't.
So, yeah, I'm not sure if the term could be used to select clusters because we have
I'm
a
back.
class.
The meeting was canceled, so we can
Yeah,
enjoy.
great. So we are just talking the how to simplify the API, and so uh, what I'm thinking is we might not need that complicated API in Karmada. For example, the topology key, do we really need it?
Hmm. Topology key, well, it depends. So the topology in Kubernetes, it was used to basically put a node into different groups, like group the node by zones, group the node by rags or the other kind of uh, perspective. For example, provider or maybe CPU architecture sort of things. So we can think about it in our case.
Yeah. For now, I don't see clear evidence that we need this because for the affinity use case, we only need to do something like, hey, I want to schedule a workload exactly to another workload to a cluster where already running the other workload. And for the anti-affinity terms, is saying I don't want to be don't want to be in the cluster where running workload blah blah. So I don't think I don't see a use case that we a workload can affinity in a group of a cluster.
I understand your thoughts. So basically, I would say that the cluster level anti-affinity or affinity would be more frequent, uh, which actually we can just start with the cluster level affinity anti-affinity, and we can wait a few more community feedback to request adding grouping clusters by the label key, and we can add it later on. I think it's we have the flexibility on that.
Mhm.
So essentially, are we just planning on relying on the existing cluster affinity definitions for the specific resource binding that already, like during the scheduling cycle, we already filter out clusters that don't match the affinities for that resource binding. So is that what you mean, Honkai, where we're just going to look at all clusters that are feasible instead of trying to use this additional label key?
So sorry.
So what I mean is during the scheduling cycle, each
Hmm.
first binding has its own cluster affinity set, right? Like it doesn't necessarily have to be set, but it can be there. And so what you're stating is we can remove this topology key and just use all clusters as feasible targets. Um, and we don't have to add this additional complexity. If a user wants to filter out clusters, they can do that using the cluster affinity definitions in their propagation policy.
Yeah. Uh, I think so.
Yeah.
Okay. So sure, I can remove this for now and add that as a non-goal of the proposal. Um,
We can add some statements say that I think by design we still have the flexibility to add it later on. We just don't want to kind of over design that. We want get more community feedback really if people really want it, we can add it later on, I think.
okay. Okay. Um, Honkai, did you also want to remove anything else in this affinity term for now?
Let me see mesh label case.
Because I think,
Just to double check, the label selector is the one has operator or not. I don't remember the details.
Operate. Sorry, what do you mean by operator?
Operator means uh, s- um, so one version of the label selector you just indicate with key and the values. Later on, there was a selector. People need to kind of indicate the key as a field and also values. That's an array, and also you can indicate the operator like to get uh, the semantic like for example uh, apps in app A, app B, app C, or apps not in app B, B, app C,
Yeah.
or just the apps, the key exists. That's the two version of the label selector.
Okay. So, I mean, if we want to simplify this, we could just map on the key. We don't have to even search for the key and value here. But
Yeah.
so, I mean, this doesn't even have to be a label selector. It could just be something like label key and then string.
Can we have a field to specify the label values? Because maybe we can define some uh, static key.
Hmm.
So in general, I think the workload affinity term can be uh, used to define the rule to find a group of workloads. So if we want to simplify this API, one idea is we can restrict the label selector on above, and for example, we don't want to support all the match operations. We just need the key value match.
You're referring to this.
Another idea is
Sorry, keep going.
we can just something like we can have a field, let's say label value my network. Um, so I'm not sure yet. So I'm not sure if we can have a quite different field. It it's just a slice of label values.
I mean, listen, the other, if you really want to simplify this, um, you could just take Kevin's idea of passing in some sort of configuration that the user can set for specific label keys that they want to match against. And then you don't even have to define any of this. You can just toggle on workload anti-affinity true, and then the configurations already get loaded in by Karmada.
Mm.
That said, like at least in our use case, we really like if we could remove everything here, the only thing we actually need is match label keys. This is the thing that we actually need.
Mm-hmm.
Match label keys. So what about the values? Are the values on different workloads the same or different?
The values on different workloads would be the same. Um, but it's essentially we have users who deploy their applications in pairs, right? So um,
Mhm.
going down to my example below, like I had been talking about, okay, this user might deploy deployment one with a label app called indexer, and then they might deploy
Mhm.
another application with the label app indexer. And we want to make sure that they're scheduled to different clusters. But what you could get
Mhm.
as well is something like deployment three app,
Mhm.
right? These would also need to get scheduled to different clusters. So schedule cluster A, filter out cluster A.
Yeah, but the deployment three has nothing to do with deployment one or two, right?
Yes, they have nothing to do with deployment one or two.
Mhm. In that case, I would prefer, indicate with both label key and the values because you are not ignoring the values. If you only identify, if you only indicate match label keys, the system would ignore the values and consider deployment one, two, three, four. They all need to uh, satisfy the anti-affinity rule.
Oh, but the way that I was thinking of indexing would be based on the key and the value.
The index is a different perspective. Indexing is just for indexing. The kind of configuration of the indexing may be different perspective of the requirement of affinity or anti-affinity.
Hmm.
Because in the indexing comes from the challenge of uh, implementation perspective. It's not from the user requirement perspective. So we'd better separate them.
Okay. I guess the way that the API, the way I thought about this was essentially we're
Oh,
matching workloads together based off the same group value.
mhm, mhm,
So like in our case, if workloads both have this label and they both have the same value, then we
mhm,
match them as part of the same term
mhm.
and that they have to
Yeah.
be scheduled to different clusters.
Mhm.
But do you have concerns with that behavior?
I don't have that concern of the behavior, just from indexing level. Uh, we want to tell the system that index all the labels that has key apps, right?
Hmm.
Uh, my idea is that that configuration is comes from a different configuration or different API. We don't need to reuse the uh, fields on the propagation policy
I see. Okay.
because that would be something like system wide. Uh, when you tell the scheduler which set of the label, only label keys or label key values to index, it's a system wide configuration.
Yeah.
So we'd better use another API to define that.
Would we want that to be a separate CRD, or are we comfortable just passing that in as a configuration into,
Maybe we can just use the Karmada scheduler configuration.
yeah, I think that's okay. Okay, just to make that clear though, if we do go with a configuration option, what would our potential configuration options be? Like, do we want to only do label keys or anti-affinity label keys? Or um, I guess if we do anti-affinity keys, the way that this would work is, I guess we could just do the match label key where if the value of that key is the same, then we would treat those applications as they need to be scheduled to different clusters. But I don't know if that like the naming doesn't really make sense to me at the moment. I would need to think of something better.
My understanding is that this one, the anti-affinity label keys, just tell scheduler to index those label keys.
Yeah, yeah.
Um, it helps simplify the from the algorithm perspective when you're trying to find out the workload that has the certain label key, right? No
Yep.
matter what value they are or they have. And
Mhm.
use on the propagation policy, the user can still indicate whether they want exactly uh, separate the different workloads has the same key value, or they just want separate everything, every workload has the same key. So I think that's a that's different perspective of to the scheduler configuration.
Yeah. Okay. I actually like that a lot. So in that case, the only thing that we would really include within the affinity term would be, I guess, two booleans. One would be, okay, do you want to set, or I guess it could just be like an enum where you define what your behavior is. And that behavior could either be match on key value or key.
Mhm.
But if we want to match on key value, I think user need to indicate the exact key value, right?
Well, the problem there is we have users who are deploying hundreds of applications. Um, if we would need to define a value, then we would need to have hundreds of different propagation policies for different values, right?
Mhm.
Um, which would also get complicated, I think.
So what if we I mean on the propagation we keep both the line 158 and the line 163?
Yeah. Yeah. And then with namespaces, we can just inherit the namespace that's already defined for the workload.
Mhm.
Right. It seems like we have two options here, because even if we keep these two definitions in the API, um, if we're passing in a configuration option to listen to specific keys, then perhaps we don't even need match label keys or a label selector at all, right? We can just have the definition for how we want the anti-affinity behavior to work. Like, do we want to match
Well,
key?
uh, there's a corner case if the workload has multiple label keys. What do we do? So yeah, that's the case we need to think about. And they may have different meaning, or according to different label key, the workloads may be divided into different groups.
Hmm.
So we if we have these two fields on the propagation policy, we are telling the system for this workload which label or label key we want to match on.
Got it. Okay.
But all the labels need to be, I mean, within the index. If the user indicated some label not with the key not in the index sets, mm, it would be ignored because we didn't index on that.
Yeah, that makes sense. Okay, let me clean up the proposal with some of these comments in mind, and I'll maybe add some options based on what we discussed. Uh,
Mhm.
and I'll tag both of you just to review. But yeah, I'll simplify this API.
Okay. Okay. Let's get it, go back to the first item.
All right, sounds good. Thanks again,
Mhm.
Kevin. That was really helpful.
Mhm.
Thank you.
Um, Right. So with the first comment, we were doing some cluster failovers. And so what I noticed is this is kind of Flink specific. What happens is when the Flink cluster or when a Flink job is being cleaned up on a Kubernetes cluster, um,
Mhm.
there are some cleanup procedures that happen. One of them is cleaning up the latest directory of the checkpoint. Um, and what we noticed is that because we use immediately as the failover strategy, we automatically reschedule all of these Flink deployments onto the next cluster. And our
Mhm.
logic for fetching the last state is essentially just, okay, let's take a look at the file system on which the checkpoints for that job have been saved to, and let's get the latest valid one. Um, so what we've noticed is that in some edge cases, um, the Flink job might still be cleaning up um, the latest checkpoint that hasn't been completed yet. And somehow we still pull in that latest checkpoint. And so when the Flink job tries to resume, it states, uh-oh, like there's no checkpoint um, there based on the ID that you've passed in. And so eventually this is able to resolve because like with application failover, the application never comes up, it gets rescheduled, and then it pulls the correct checkpoint, right? So there eventually this does reconcile. But what we were wondering is there a way for us to programmatically delay the rescheduling so that we can wait for all of the Flink jobs to actually be cleaned up from the cluster first? Because I think when it comes to, I think the other purge modes, There isn't really a purge mode that waits for the job to be successfully deleted from a cluster. Um,
Yeah.
and additionally, like if a cluster is down, you like an actual like this is in the case of maintenance, but if the cluster is actually down, you're not going to be able to ever get that deletion confirmation, right? So what we're wondering is if there's some sort of programmatic way to delay the rescheduling in Karmada after eviction.
Okay. Um, I want to ask a question. When the Flink deployment done the clean up, uh, after the Flink deployment object has been removed from the etcd, does that mean the cleanup is done?
Yes. So once it's been fully removed, it's finished. The thing that we noticed is just that when you're deleting like
Mhm,
150 Flink deployments all at the same time, you're going to notice
mhm.
that some jobs take a little bit longer to fully delete, just because like the Cube API server is trying to go through that entire queue of requests, right? And it's kind of we're almost like DDoSing the Kubernetes cluster because there's so many events that it's processing. Um, so it's the case in which some jobs haven't been successfully terminated yet. Um, and in that case, they haven't cleaned up the checkpoint just yet.
So I see. Uh, is the
It
root
sounds
cause?
like make sure you clean up, finish the right before scheduling new instances, right? And your case is that the cluster is healthy. You just trying to migrate the workloads, right?
Yeah.
Yeah. So it's kind of similar to max surge zero in the deployment API.
Yeah.
Mm,
Yeah.
right, right. I
Clean
mm,
up first, then create a new, or
yeah.
then schedule new a new part.
So yeah. So I think the failover purge mode immediately is exactly want to do that. So the root cause, I guess, are we talking about the deletion behavior? In Kubernetes, there are two deletion strategy. One is the background and the preground. So
Uh,
so
uh, so okay. I think we lost the disconnection. Okay, you come.
oh yeah.
So my understanding that currently our purge mode, I just looking into the I'm just looking into the documents. We have intermittently, graciously, and also never. So intermittently means that we kind of ignore the system delay of doing the cleanup. We
Yeah.
just intermittently reschedule, and graciously it's kind of make sure trying to reduce the downtime, so it will actually kind of try create new you schedule the application to new cluster before evicting the older part, right?
Yeah.
So I think that's the so in a what is called what's that word what's that word if we want to provide a symmetric mechanism, we need another purge mode, like make sure the old part of the application clean up first, then create new. So basically, the idea is kind of similar to uh, max search. What's the opposite of the max search? Uh, what's the opposite side of the of max search? Max unavailable. So yeah, graciously, it's kind of max unavailable is zero, what, right? But now we are kind of trying to we need max surge is zero.
Yeah.
Yeah.
I'm curious though, would we want to include some sort of timeout for that? Because like for example, this is fine if the cluster is healthy and we're just draining it for maintenance. But if the cluster is down, or there's some sort of disaster, we're never going to get the confirmation from that API server that the resources are deleted.
Yeah, I think timeout makes sense. We also currently have a grace period seconds, which is timeout for the graciously mode.
Yeah.
Uh, do you get the idea?
I still not quite sure if we um, find the root cause or
I
for
mean,
for my
we currently sorry, what's your question?
for my understanding the root cause is uh, the root cause is the controller um, delays the Flink deployment in a background mode. In that case, the Flink deployment is just as the Mihashi added in the notes. At that time, the Flink deployment still is in the face of a deleting, but he hasn't been uh, finally removed. But the Karmada controller think it has done the job. Um, then the controller started to create another brand new Flink deployments in another cluster. So that means the behavior actually essentially violates the guarantee of the immediately term.
Yeah, I mean the root cause is that the Kubernetes cluster that we're
Mm.
deleting the deployments from is just taking a long time to fully delete everything. And so we rely on a Kubernetes as a service team to spin up our Kubernetes clusters for us. So we're actually going to meet with them next week after the holidays to discuss whether we can vertically scale um, the control plane a bit just to keep up with some of the demand of these like bulk deletions and bulk reschedules. Um, so maybe that way we can kind of like decrease the draining time that it takes. Um, but this is just something that I was also curious, like if Karmada already supports. It seems like it doesn't. So um, I'll keep thinking about whether there's an additional use case here. The other thing is we as a team need to investigate why we even pulled the latest checkpoint if it was marked for deletion by Flink. Because our understanding is that we check the latest checkpoint that's been written that also includes a manifest file. Because the manifest file is the last thing that's written by Apache Flink when it's finalizing the checkpoint. But it seems as if for some reason the manifest file already exists, but Flink still deletes that latest checkpoint. And we need to actually rely on the second to last checkpoint. But again, this is only in cases where we've rescheduled an application and the previous application is still running. Um, so it's a bit of an edge case. I think what we'll do first is just investigate our latest checkpoint fetching logic and root cause that. And if we still need to have some sort of delay for rescheduling, we can let you guys know.
Sure, sure. But do want to double check. Do we wait the old? I mean, do I wait for the work being deleted until we create new? Until we reschedule?
We so we use immediately and we don't wait
Mhm.
for the workloads to be deleted first.
Right, that's my understanding. So yeah, because the system it just doesn't it just don't doesn't wait for that.
Yeah.
So that means you can kind of figure out. I mean, you can still speed up the cleanup, but there's no guarantee because the system just don't wait, right?
Yeah.
I think yeah, that's the issue.
That means maybe we can uh, have a way that user to specify
Yeah,
the deletion strategy. The
yeah.
strategy like including pre-ground or background. For now, I see the default strategy is the background. So in that case, we actually need the pre-ground mode.
Do we have this listed in the Karmada documentation somewhere? Just so I could read it?
No, no. For
Oh, we
now,
don't.
the deletion strategy is the default behavior. No support, not support to let user to specify, but we can have it. I want this feature for like 4 years.
Nice. Okay. Okay. All right.
How about that, Mihashi? Uh, can you open an issue to for this case, and we can talk there and ensure we have a clear a clear root cause analysis, and after that we can move on to discuss further about the solution, the solution and the next move.
Yeah, I think that makes sense.
Okay, that's interesting case. So now, are we ready to move to the last topic?
Yes, there is one thing that I think one of my coworkers brought up in the issues on Karmada. What we noticed is that when using the federated resource quota, updates
Mm-hmm.
to the parallelism didn't
Mm-hmm.
get honored and didn't get blocked by the federated resource quota. But I think based on latest comments, we just have to rebase to 1.15 and perhaps that should fix our issue. So I'll update y'all on the ticket after that. But yes, please go ahead with the next item.
Okay. For that, I think we already fixed it at 1.15, right?
Yes, I think that's what I don't know how to pronounce his name. It's ZH
Zhuang, Zhuang,
Zhang.
Zhuang, Zhuang,
Zhang. Okay.
Yeah,
Zhuang.
yeah.
Oh, okay. He mentioned that it should be fixed in the recent 1.15 release. So let me.
Yeah. Oh,
But okay, we'll try rebasing to 1.15 and then try that out.
I check that issue is resolved by is resolved in master print or the release 1.15.
Got it. Okay.
115, right?
1.15. Yeah. I'm on version 1.14. I don't think I'm
Yeah, makes sense. So what we'll do, we'll rebase on 1.15 and see if that fixes the issue.
okay. By the way, does this guy from your team or not?
He is on my team, yeah.
Okay. Okay. Okay, let's move to the last topic. So, the plan of the KubeCon Europe, I think we can have we can send the CFP for the maintainer track and project Latin talks. Maybe also we can have a booth, Kamada booth, and as well. Do you think do you guys think we can have a project meeting there, just like what we did this year in London?
Yeah, I think so.
That would be nice, right? We can sit together and have a chat or discuss something, right?
For sure.
Okay, so let's go through the CFP. So I just add some new features here, and we can show what we have done since last year, and some real world case studies, use case, right? That makes sense to you?
Yeah, I think that looks good.
Okay. So another important thing, as I mentioned in the Slack, so if we have more than 2 speakers, we must need a female speaker. So for now, we have I think we have 5 man here. So so we need a female speaker to replace one of us. Do you know this guy? I don't know how to pronounce his name. He
Richard.
from Recharge.
Yep.
Recharge is from the Jaws team, right?
He's from my team.
From which team?
My
Your
team.
team?
Yeah.
Your team. Okay. So you talk to I'm sorry, the workmates that female that
Yeah. Tessa is okay.
Tessa.
Is interested.
So does that mean Tosa, right? Sorry.
Tessa. Like
Tessa. Okay.
Yep.
Tosa going to replace Ritaji.
I haven't
Right.
probably, but I haven't talked to Richard yet. I can send it. But I guess it will be it.
Yeah, that would be great. I never talked to this guy yet. I just heard from Joe. He want to show an interesting use case about to let Karmada cache large model, right?
Yeah. We have a use case to integrate it with Kaiser, AutoCache, and we use Karmada to manage it. We can also bring that up in the use case.
Yes.
Yeah.
If Tessa can help introduce that topic, so we can let sorry, I don't know how to.
Oh, I have sent in the chat. This is her. It's a thing. Okay.
Sending what? Okay.
I sent in the Zoom chat.
Yes. Okay. Okay. Sound good. Sound good to me. Can you talk to Tessa? She knows the use case, right?
Yeah, she knows the use case.
Hey, wonderful. Okay.
I can also invite her into the group chat.
But before that, do we need to talk to Richard?
Yeah, I will also talk to him before.
Okay.
Yeah. Thanks.
Okay. Sound good. So, looks fine now. Oh, so once we have a maybe I can send the CFP this month. So maybe next week, this week. Okay, so if you want to update something on on the CFP, now it's the time. Before send the CFP, I will leave a message on the Slack channel. Okay. And we can start to prepare the slides after we get the notification. Once the safety is accepted, then we start prepare the slides. Okay.
Sounds good.
Okay. So since we don't have any other topics now, so
I just want to discuss a bit more about the project meeting. It would be very helpful. We started preparing early. I mean, if we can, like give a call through the community channels to collect interest of the people
yeah,
that like to attend, and then also if they have any interest on any specific topics.
yeah,
And ideally, before the submission, it would be good, but it's still valuable throughout all the time until we are there, I think.
yeah, sure. Sound good. Yeah, makes sense. Maybe we can have a Google Doc to mention to list the topics who want to talk there. Or,
Yeah.
yeah. Okay, makes sense. So see you next time.
See you.
Right.
See you.
See
See
you.
you. Bye.
Bye.
Bye.